Okay, so we're going to start off by drawing a free body diagram of the truss and solve for all the external reactions. So I'm going to draw this one smaller than the original. And right here we have this reaction. We have a 2000. Then I'm going to label them. This is joint A, B, C, D, E. And then I'm going to solve for the external reactions. And so in my x direction, there is no force. In my vertical direction, or y, I have AY plus EY minus 2000. Then I'm going to take the moment about A. And so the 2000 force is 2 inches away. And the EY is 4 inches away. So that tells me that the EY equals 4,000 divided by 4, which is 1,000. Then I'm going to plug this back in up here. And so I have AY plus 1,000 minus 2,000 equals 0. So that tells me that my AY equals 1,000. So now I have all my external forces solved. So I'm going to start at joint A using the method of joints. So at joint A, I have this. So for joint, I have AC, AB, and this is a 60-degree triangle since it's an equilateral. And I have a force of AY acting up that is going to be 1,000. All right, so I'm going to start this off by solving for all my forces in the x direction. So the sum of the forces in the x direction equals F AB cosine 60 plus F AC. All right, so then I'm going to sum up the forces in the y direction. And I have FAB sine 60 plus the AY force. And we know the AY force, so we can solve the FAB, which will be 1,000, well, negative 1,000 over sine 60, which equals a negative 1,154.7. So I can plug this back in up top to get my my FAC. And so after plugging that in, it tells me that FAC equals 577.4. So far we've solved for AB, which is negative 1154.7, and we solved for AC, which is 577.4. All right, and then I'm going to go to joint B, which looks something like this. And we already solved for AB. So we have BD and BC to solve for. So I'm going to sum up the forces in the x direction again. and that's going to give me FBD minus FBA, which we already know, cosine 60 plus FBC cosine 60. All right, and then I'm going to sum up the forces in the y direction, which are negative FAB sine 60 minus FBC sine 60. Okay, so this tells me that FBC equals, let me write it down, FBC equals negative FAB sine 60 which tells me that FBC equals a negative 1,154.7. Add my negative sign. And so I can take this and plug it back up for the X forces since I have my FBC solved. And it will tell me the FBD, which equals, after plugging all that in, it tells me that it equals 1,154.7, and that's a negative. And so now I have my FBD, 7, and I have my FBC, okay. So now I'm going to go to joint C. All right, so for joint C, I have CD, I have CB, which we already know, I have AC and CE. So I'm going to label these CE, CD, CB, and CA. So I'm going to start off by summing the forces in the X direction, which I have negative FAC minus FBC cosine 60 plus FCD cosine 60 plus FCE. And then I'm going to sum the forces in the y direction. And I have FBC sine 60 plus FCD sine 60 minus our 2,000 pound external load. So since we know FBC, and we know this force, we can solve for FCD, and that tells us that FCD is equal to 1,154.7, and then we can plug that back into the X forces to solve for FCE, and it tells us that FCE is 577.4. So I'm going to flip back over page and fill out my chart. So now I know that CE is 577.4 and CD is 1054.7. And so now all I have to do is solve for DE. So I'm going to start at joint D. All right. So at joint D, I have all right. So right here I have BD, then I have DC, and I have DE. So for this one, I'm only going to sum up the forces in the y direction to make it a little simpler. So for here I have FCD sine 60 minus FDE sine 60 and then I'm going to solve for FDE, which equals negative 150 sine 60 over sine 60, which tells me that FDE is equal to 1154.7. So I'm going to flip over and fill out the last section. And there you have it. That is how you solve a truss by using the method of joints. My name is Anthony Hardiman, and it was a pleasure doing business. Thank you.